Hello, my name is David Schultz. Welcome to Our Earth, its climate, history, and processes. In this lecture, I want to talk about the supercontinent Pangea. We've seen this graphic before. This indicates the age of the seafloor as measured by both the magnetic stripes, determined both as a result of radioactive dating and the paleomagnetic anomalies that we see on the ocean floor. As you can see, the age of the lithosphere is red, relatively recent, near the spreading centers, and relatively old in the blues and magentas, and these lie near North America, North Africa, and within the Mediterranean. Now, what we can do is run this magnetic tape recorder back and then fold that ocean crust back into the spreading centers so that we can see what the Earth looked like in the geologic past. And we can also use fossils, paleomagnetism to determine the locations of these continents in the geologic past. So this is an animation produced by Don Blakey of Colorado Plateau Geosystems. And here you can see the present Earth and in this format. The black lines represent subduction zones. The red lines indicate convergence boundaries where plates are coming together. And you can see the spreading centers in the beige color. As we run this magnetic tape recorder backwards, you can see the folding in of these continents back into the spreading centers. So here we are back to 35 million years ago, where the Alps and the Himalayas formed. You can see this entire orogeny, region of mountain building that occurs as these continents came together. Which continents? Well, you'll see this as we run back in time. We see the collision of Africa with Europe and Asia. India was its own continent, and it had been moving northward towards Asia. North of India was what was called the Tethys Ocean. The Tethys Ocean no longer exists except for its remnants in the Mediterranean Sea. As we go back even further, we see the continued southward movement of India. In other words, India is moving to the north. The Atlantic is starting to close up as well. So this was the point where rifting had started in the Atlantic, particularly in the southern hemisphere. And so by the time we get to 120 million years ago, we see that the South Atlantic has closed up. We see the formation of the Caribbean. We see India, which is now connected to Antarctica, starting to rift apart from Antarctica and Africa. And so as we go back even further in time to 150 million years ago, we see the formation of two larger continents. Laurasia in the north, which is composed of North America and Eurasia, and Gondwana in the south, composed of South America, Africa, India, Australia, and Antarctica. Going back even further, we now see Laurasia and Gondwana get even closer, so that by 220 million years ago, they are all one single continent, kind of a C-shaped continent, and this large sea opening up to the east to the Tethys Ocean. To the west of Pangea was the Panthalassic Ocean, and this represented the early Pacific Ocean. Going back even further, we see the continued solidification of Pangea. If we go back to 260 million years ago, we see that a large portion of Pangea existed near the South Pole, and associated with this was a polar ice cap on Gondwana at the time. If we go back even further, we start to see the assembly of Pangea as oceans close up between North America to the north and Gondwana to the south. We see this red convergence zone. Going back into the Devonian 300, 400 million years ago, we see Gondwana now mostly in the southern hemisphere, and now North America actually in the southern hemisphere. The gap between North America and Gondwana was called the Iapetus Ocean and the Rheic Ocean, and the Paleotethys to the east. So as these two larger continents started separating out, then the Iapetus Ocean grew in size. We go back to the Middle Ordovician, where now there's multiple fragments, and Gondwana is now on the far side of the globe. That's why we see it split in this diagram, both to the west and the east, but it's on the opposite side of the globe from North America, Siberia, and Baltica. Going back even further, we see now that these continents are coming together again. And around 600 million years ago, we call this supercontinent that existed before Pangea, Rodinia. Rodinia is characterized by all the continents being together 600 million years ago, and again, extensive glaciation in the polar regions. Here's another view of Rodinia, and we can see how these different pieces have come together. And if you go back even further than Rodinia, another back to 1.5 billion years ago, then there was another supercontinent that existed before that with a different arrangements of these continental fragments, these cratons, and that supercontinent was called Columbia. And so, now that we've seen how Pangea broke up into the continents as we see them today, let's look at this magnetic tape recorder again that we see from the seafloor. And now you can see, based on the ages of the ocean crust around the world, these processes that we were talking about in the evolution of these plates. We see the opening up of the North Atlantic Ocean here around 180 million years ago. We see the opening up of the South Atlantic Ocean around 100 million years ago. Here, we see the very old crust here, almost 300 million years in the Mediterranean, what's left of the Tethys Ocean. And we see now the suture between India and Eurasia, where there used to be a huge ocean, and now the rifting created between India, Australia, and Antarctica. And so now let's run this animation forward. First we'll show the breakup of Rodinia, and as it moves on to the formation of Pangea here, the breakup of that into Laurasia and Gondwana, and now running forward to the present. So, as I pointed out, the Earth has gone through several of these supercontinents, Pangea being the most recent, but before that, Rodinia, before that, Columbia, and then there's even evidence before that of an earlier supercontinent around 2.7 billion years ago called Kenorland. What we see then is the formation of these supercontinents every 500 million to 1 billion years in this cycle. And we're going to see more about this cycle in an upcoming lecture. So to summarize today's lecture, if we run this magnetic tape that was recorded backwards in time, we see the reconstruction of a supercontinent, Pangea. Geologic evidence also shows that there were probably supercontinents before that, and there seems to indicate then a cycle in the formation and breakup of these supercontinents.